Hi, I'm Sabir Ahmed. So we are here. We will learn about georeferencing and data preparation in this lecture. So in this lecture, we will cover mainly two topics: and how to georeference a map, and second, how to project that georeference map we have already georeferenced. So these two broad topics will be covered in this lecture. Okay, so get started. Let's get started. uh, okay, so what is this? So let's see, this is the scan map we have available at this moment. So we will georeference this is the analog map, and computer doesn't know where is latitude and longitude. We we see here that this is the line. If you draw a line along this line, then we will found this line will represent the 88-degree longitude, and if we found this, if we draw a line along this, then this line will represent the 26-degree latitude, right? Okay, so and the intersection point of those two lines will represent the point, and those and that point will represent the 88-degree longitude and 26-degree latitude. So in this way we will define the map, and we will input those data to the computer, because computer doesn't know uh, what is the latitude longitude of this point. So at first we have to do that, and we will do that using the georeferencing tool in ArcGIS. Okay, so let's start. This is the ArcGIS, and we have to add the map first. Okay, so you will see the warning map, and you will see that this is the unknown spatial reference, definitely, because this map doesn't have any spatial reference, and that is what we are going to do. And we are going to reference this map at first, georeference this map. Okay, so they added this map, and how will the georeference this map? The most interesting thing is that you will look, this will show the unknown units, because this still now this map doesn't have any units, and this lacks any latitude longitude, right? Okay, so using georeferencing tool we will able to make this map digitally, and which will represent, which will show the true latitude longitude, so that we can identify the distance, so that we can make some shape files of points, so that we make some polylines, polygons, something like this, whatever you want. Okay, so how we are going to do this? We are going to do this using this georeferencing tool, and if this georeferencing tool is not available here, the same way we have um, taught you in previous lecture how to add this map, add this tools. Okay, so this is the georeferencing tools, so we can add it here. Okay, so these georeferencing tools, these are the tools at control points. So using these control points, we will georeferencing this map. We have to identify, we have to at least identify the 4 points, and we have to input the 4 points longitude latitude data, at least 4 points data, so that this map can be digitized with those four maps, and other points, other location points, this ArcGIS map will automatically detect. So how we can do that? Okay, so okay, so if we draw a line along this 89-degree and 26-degree, we'll find the point, right? We will represent 89-degree longitude and 26-degree latitude, right? But the one of the most challenges, how we will find that point exactly, right? So it may be here, it may be here. It is very difficult to ask. Okay, so but we have a technique to do that. Okay, before going to do that, we will have another function. We have to stop this auto adjust function, and why we are going to this, and I will tell you later. This will very important. This will really help you throughout this process. Okay, so I have stopped this auto adjust process. Okay, so my next target is to find the point where these two lines intersect. Okay, we how we can find this out? Okay, we can find this out using the rectangle tool. Okay, so if we draw a line using this point, for example, this. Um, then we'll find the point here, and this is the line and this is the line which represents the cross section of this cross each other, this line, and this line represents the longitude of 89 degree, and this point represents the latitude 26 degree, right? So if we can define these points and such other 3 points, then computer can easily detect the all other points in this map. Okay, so how we can do that? So we can do that using the add control points. Add control points. So and if we place here, then at first we have to settle this down. Yes, we have to at first left click to fix the point, then we have to right click. Oh, sorry, some maybe some wrong thing, and we are going to delete this. And so we have to at first add, then we have to right click. At first we have to click the um, left click, then we have to right click to input x and y data. So our x is here 89 degree longitude and latitude is 26 degree latitude. Okay, we've got another point. In such a way we'll find the three other points. Okay, so we can do that using the 90 and 26. So if we zoom this, and we'll find the point. 90 20 is the 90, is the 26. Okay, uh, we can do that using we'll add the longitude points here. Okay, don't worry, and you can use this and this line. Uh-oh. Okay, this is the 24 and this is the 89. So if you can delete this, it will be more easier for us. Okay, draw a rectangle. This point. Where's that? Okay. Okay, this is the point where this is the 24 degree latitude and 89 degree longitude. So we can use this. 89 degree longitude and 24 degree latitude. Okay, so we have got another point, and we are left only with one point. So we can do that with 2590 something. At least we need 4 points to georeference a map. Okay, so we can do that using 9025. Okay, 90 we can draw a rectangle so that we can identify the point. Yeah, okay, so we do that 90 25. So x represents the longitude, y represents the latitude, right? Okay, so 90 25. Okay, so we have got 4 points. We've got 4 points. So if you want to see the table of 4 points, then you can see that here. Okay, now we can what we are going to do, these are 4 points: 1 2 3 and 4. Okay, now we'll auto adjust the map. Okay, why we didn't select this map initially? Okay, we didn't select this auto adjust because if we did this, then after getting one input point, the map automatically adjusts, right? As a result, the map turns around so that it couldn't work very properly. That's why we have to head off this. So now we can auto adjust the map, and this said you will get a warning message, and we shall say that these are not well distributed and correct. Definitely, we have found the 4 points arbitrarily, and these are not definitely well distributed. So don't worry about this warning message. You have to just click OK, And if you see right now if you click on the right full extent button, then you will get the map. Yes. Okay, if you press this map, if you want to see the data, the residual error, then you can find it out. Like in number 4 points, the residual error is higher, right? Okay, so if you want to delete this, you can, but more you will get the points, more you will less you will get the residual errors. Okay, so we can do the adjust. Yeah, automatically it will adjust and it will minimize the residual error up to 0. Okay, second error. Then we have final task. We have to update georeference because we have to finalize this. Update georeference. Okay, so initially what we have seen the arbitrarily random values here, but we see here the uh, uh, not arbitrary, and what we see what we are seeing, we see these are the 89, 18, 88, 89, 90, right? So we can easily say that these map represent the true latitude longitude values here. So if we want to examine this, for example, this line represents the 25. So approximately if we see the latitude values approximately 25.005, and this line represents 87.9 and 899 longitude values. Okay, so these are the initial part of georeferencing. Okay, so we georeference this map, but in our projection system, what we have what we have taught you, have taught you that to make a data, to make a scan map digitally for our analysis, we have to do the 3 points. Number one, add control points that we have already done. Second, we have to project this map. Okay, so these are raster. So we have to project this map for our uh, analysis, for our final preparation, for our final work. Okay, so we have to do that. So the first step has already been done at control point. The second step is define its geographic coordinate system. Okay, so we can do that using the data management tool we have already seen in the last lecture. So projection and define. So define its projection. So um, if we okay, it's taking time. We are waiting for its projection definition. So let's see. It's taking time. Sometimes it may take time because it depends upon your computer configuration. If your computer configuration is good, then it will take less time, and vice versa. So what does this indicate? This just indicates that my computer is getting some trouble. Okay, come on. Okay, so let's start. Define projection system toolbox, and we can go there, and data management tool. So from here we can go projection and transformation and define its projection. So circling. Okay, so if we get the map from here, borrow, and what we will see this coordinate system is unknown, but we have to define it. So we can do that, and we can do that using the select geographic coordinate system world WGS 984. Okay, so if you press OK, then it will get automatically done. Uh, getting its projection system is getting definition. Yes, its projection is defined. So my third step is to project this map project this map using the raster, because this is the raster file. So you have to project this map using the raster project. So if we get the map from here, then we will see its input coordinate system is GCS WGS 9084. So output coordinate system should be the projected coordinate system. So UTM WGS 9084. The Bangladesh, this part of map is northern hemisphere, so we see a northern hemisphere, and we see its projection is 45 zone. 45 zone. According to your map, you have to define your own projection system. So it's getting, and we can separate this data, and we can see data. Okay, let's make a folder, projected data. Projected projected data. Projected data. So we put so in here say P here this projected data projected CPP borehole. So I put P here to indicate that this is the projected map. So say map. So press OK. Try to keep projected data from projected data from non-projected data, so that sometimes ArcGIS map conflict with those data if you put those projected data and non-projected data together in the same folder. So what you have to do, what I recommend you to keep those files separate from non-projected data. Okay, so we are already done. We have already done this. So if we click the view and data frame properties, what we will see, we will see this is the unknown, is still unknown. So if we want to see the data, we have to reopen the ArcGIS map and reopen this projected data. So wording, then you will see the projected data. It will show the projected map. Okay, if we this and this from the projected data P borehole at yes, this is the projected data, and if you see data frame properties, yes, it will see WGS 984 UTM zone 45. It will see the projected data. Okay, so this will see its original units in meters, because we do not want to measure anything in degree, but we want to measure this meter. We can easily change this using the data frame properties. If you want to go to the general section, then we can change the in kilometer or meter, so whatever you want. Generally keep this in meters. So if we want to overlap with this map, if we do have other data, say with same projection system, then what we will see, uh, for example, we do have same projected Bangladesh boundary data. So if we want to overlap with this, let's see what happened. This is the district project, and this is the district map of Bangladesh, which have the same projection system. If we want to add with this, then what we'll see? Yes, it adds and it overlaps, and it coincides with this, right? Okay, so if we change the map hollow, yes, it does, and if we change its color, what we'll see? Color, yes, it overlapped with each other. So we prepare, yeah, almost coincident. We have some, because almost coincident. We have some distances with this an original map. Yes, if we did add it with some more points using georeferencing tool, then we might have not seen this error with this, but it's alright. Okay, so this is the part in this lecture we have learned how to georeference the scanned map, and how to project this map, and how to analyze this map, whether this is georeferenced or not, or projected or not, using the other same projected map. If this overlap with each other, then we are done. If it doesn't, then there is somewhere are wrong to this. So thank you very much. If you do find any problems or something like this, please let us know, and we'll try to solve those problems. Thank you.